Today we're going to talk about atoms and basically give a little periodic, or not, sorry. Today we are going to be talking about atoms and give a little timeline of the atom. In 400 BC, Democritus came up with the idea of the atom. It was more of a philosophy. He didn't have any scientific evidence. He just thought that there has to be some portion of matter in which you can no longer divide. His idea basically was that you could keep putting matter in half until you get down to the atom, and at that point, you can no longer keep cutting that matter into half. He also saw atoms as tiny solid spheres. You can see that in the picture right there. Okay. And then they didn't really think too much about atoms again until Dalton in the 1800s. And Dalton's theory consists of three specific ideas. One is that all atoms of a given element are alike. Atoms of different elements can join to form compounds, and atoms cannot be divided. Here you can see kind of Dalton's atomic theory. And then this shows the model of a model of a water molecule. And he just believed that these atoms join together to form something bigger. And he was a chemist as well as a meteorologist, so he had a lot of scientific evidence to back his theory. Okay. The nucleus of the atom was discovered by Rutherford during his gold foil experiment. He used this gold foil experiment to kind of refute what J.J. Thomson had said, and later on we're going to watch a video over the gold foil experiment, so I'm not going to spend too much time explaining it, but basically it just consists of shooting alpha particles at a piece of gold foil. And what Rutherford discovered was that at the center of the atom, there's a very dense but very small nucleus, and that it was positively charged or made up of protons. We also know now that there are neutrons. Rutherford did not discover the neutrons with the gold foil experiment. We also know that the nucleus makes up all the mass of the atom. So that's where all the mass is concentrated. Okay. After the gold foil experiment, Chadwick discovered the neutron. Basically, they did that, basically they made that discovery because the mass of the atom did not correspond to the positive charge of the nucleus. So it meant that there had to be a neutral particle with the same mass of the proton, and that would be the neutron. Surrounding the nucleus are electrons, which are negatively charged. They move around the outside of the nucleus in a cloud. They don't really make up any mass of the atom because they are going to be around 100,000 times less massive than a proton or a neutron. So they don't make up any of the mass of the atom. It'd be like worrying about pennies in your pockets when you're getting weighed. And though they don't make up any of the mass, they make up the volume of the atom. If the nucleus were the size of a marble, the whole atom would be the size of a football stadium. So they take up a lot of space. Bohr said that atoms moved in set paths and had distinct energy levels. Atoms do not have a charge. That is because they have the same number of protons as electrons, and this causes the charge to cancel and make the atom neutral. Bohr's model, his model he came up with in 1913. He said the electrons moved in set paths around the nucleus, which A picture of that was on the previous slide. And he also said that electrons had specific energy levels. He was correct that energies have specific energy levels, but he was incorrect in the idea that they moved in set paths around the nucleus, kind of like planets orbiting the sun. So that was an incorrect idea. In 1925, they discovered that electrons behave more like waves on a vibrating string. They also discovered that they have areas that they reside in called orbitals, but you can't find the exact location of an electron. And you can see here's some more modern models of the atom. Determining electron location, electrons are moving very quickly and you cannot locate the exact position of an electron. Scientists basically just calculate the chance of finding an electron within a certain place in the atom. The areas where you're likely to find an electron are called orbitals, and we'll talk about those here in a second. Energy levels. The number of energy levels in an atom depends on the number of electrons. The first energy level holds 2 electrons, and the second energy level holds 8 electrons. We'll be using those to help make atomic models later on in the unit. Orbital is a region where it's likely to find an electron. We have 4 types. They're called S, P, D, and F. S orbital is in the shape of a sphere and can hold 2 electrons and is the lowest energy level. And then here's a picture of that orbital. P orbital is dumbbell shaped and can be oriented 3 different ways in space and can hold up to 6 electrons. D orbital is more complex, and then F orbitals are the highest complexity. Here's a picture of the p orbital. Here's the d orbitals, and there are no f orbital pictures. Valence electrons are just the number of electrons in the outermost energy level. These electrons are very important because they determine the atom's chemical properties and the ability to form bonds. We'll be studying valence electrons in relation to the periodic table, and they're very important throughout the whole unit, so it's important to remember what a valence electron is. And that is it for today.